Hello everybody. Today I'm going to be showing you a few common lab procedures that you're going to use in this class and in other labs in the future, hopefully. They are going to be ones that you're going to come in and practice as well when you come into class after watching this video. Those lab procedures include things like using a pipette. They include how to use a filter correctly. They would include how to break, polish, and bend glass tubing for experiments. And lastly, how to collect the gas using a pneumatic trough. All right, up and at 'em. So we're going to start off with pipettes and how to use pipettes correctly and the different types of pipettes. Here we've got a graduated pipette. Graduations mean markings, and so this is a graduated pipette because it has many markings to indicate water levels. This is a volumetric pipette. It has only one marking, but that one marking is for 10 milliliters. And if you look at what it says here, it tells you how accurate it is. It says this one is, to this line, 10 milliliters plus or minus 0.04 milliliters. And so this is going to be a very exact amount if we can get to that line. These are transfer pipettes. They're disposable. You should not reuse them. This one somebody used already and it should have been thrown away. You can't really clean them. They're not really meant for measuring. This one has measurements, but they're very approximate. And when you suck water up and move it from one place to another, they'll often drip a little bit if you're not careful. And so they're really just meant to put water or solutions or other liquids into other measuring equipment, like a graduated cylinder. To use one of these pipette tips, whether it's graduated or volumetric, you would use one of these called a pipette bulb. What a pipette bulb does is it provides the suction to draw water or solutions or other liquids up into these pipettes. There are 3 letters on these. Sometimes there will only be 2, and if you look in, at each letter there's a metal ball bearing, and that's really a valve. And so when you press this letter, it opens that valve. So when I am not pressing any of the letters, all of the valves are closed and I cannot squeeze this. But when I open this valve, I can squeeze it. And if I let go of the valve closes and it does not let in any air. There are different letters that do different things. So A means that this is the valve that you press while you expel all of the air. A for air. S is the valve that you would use once you've inserted the pipette tip, and it means siphon or suction. And so you would insert the pipette tip into your liquid, you would press the S, and it will apply suction to siphon the liquid up. Be very careful that you don't go too quickly, because though this is just water, sucking up acids or other liquids like acetone into the pipette bulb can really damage them and also make a mess and contaminate. And the last button is E, and that is eject. And what that does, when you press E, it lets the liquid flow out of the pipette tip. Because pipettes, especially the volumetric pipettes, are meant to be so exact, if there are any last drops of water left in the bottom of the pipette tip, the way to get rid of those is to press the E and push air into that hole with your other thumb. So I'm using one hand to press the E, and one thumb to push this hole to apply a little bit extra air in. So you should practice using both. You don't want to insert the pipettes too far into the pipette bulb because they could break, or because you could be blocking the valve. So if you stuck it all the way this far, you would press the E, but nothing would happen. If you're having trouble getting the pipette tip, because these are wider, into the pipette bulb, a little bit of water is a good lubricant between glass and rubber, which we'll use later on at the end of this set of experiments. So again, A to eject the air, S to siphon, and once you are really trying to actually measure things correctly, whether you're using the graduated pipette or the volumetric pipette, you actually will suck up past the line. Like on this, you'd go past the 0 line, or on the volumetric pipette, you would go over the line. And then you would very carefully, while looking at the meniscus, hold the eject button until it is right at the 0 mark. And then you would be able to move your pipette tip, making sure that you're holding both to where you're going to eject the liquid. After you feel like you've practiced enough and you're ready to see how good a job you can do, you're going to test your skills by using the volumetric pipette and a small beaker and a balance to determine the density of tap water. Now, once you're ready to test your skills, you're going to see how well you can determine the density of tap water by measuring its volume and its mass. Now, I'm not going to have you put water directly onto a balance. You're going to be putting it into a container. It's going to be important to know the mass of this container so that you can subtract that out when you take the mass of the container with the water in it. You're going to know the volume of the water because you're using a volumetric pipette. And so this, because it is 10 plus or minus 0.04 milliliters, this is going to give you such high precision that you should be able to go to the hundredths place when you would say that this is 10.00 milliliters by measuring to this line. I've made sure before that my balance was correctly zeroed out. You should double check that before you put on the piece of glassware. Remember, the best way to measure with the balance is you start with the largest slider, move it over one, and that is too heavy, so now I'd move to the next one, and I'd start at the heavy end, and I would move my way back until it is a little bit too light. All right, it's balanced now, and we can see that the empty glass beaker that I'm using weighs 31.29 something grams. I'm going to call it 31.296 grams. Next step is to take this off and very carefully use the volumetric pipette to pipette in 10 milliliters of water. Now again, what I'm going to do is I'm going to press the S for siphon or suction until I get slightly past the line. And now I'm going to very carefully look at the meniscus and press the E button until the water level is right at the line. Then I'm going to move this over, and I'm going to keep pressing the E until all of the water has been let out. Then lastly, while holding the E, I'm going to press my thumb on the opening so that it gets the last couple drops of water out. I'm going to mark down my volume of water as 10.00 milliliters plus or minus 0.04 milliliters. I'm then going to take the mass of this, the water, and the beaker together. Alright, so now I've got 41.37 something grams. I'm going to estimate that something as a 3, so it will be 41.363 grams. So those are my only data. We move on to calculations. We need to find the mass of the water and then divide it by the volume of the water. To find the mass of the water, it would be the difference between the two masses, our final mass, which was the beaker and the water, subtracting the mass of just the beaker. So here I followed sig fig rules. This was a subtraction. This went to the thousandths place. This also went to the thousandths place. And that means that my answer should go to the thousandths place for the mass of the water. Now lastly, the density of the water is to take its mass and divide by the volume. This is the answer that my calculator gives, but based on sig fig rules, I'm going to have to round. Because the volume has 4 significant figures, my answer should only have 4. Right now it has 5, and so I'm going to have to round it to 1.007 grams per milliliter. Alright, so in this part of the activity you're going to be practicing filtering, and the way that you're going to do that is by mixing 2 different things into some water that's in a beaker, and then you're going to filter that mixture through filter paper that is being held in the funnel. You can see the different things that you're going to measure. I've got the mass of the beaker, it's already on there. I'm going to add in a small scoop of calcium carbonate and then take the mass of that. I'm going to add in a small scoop of sodium chloride and retake the mass of the beaker, the calcium carbonate, and the sodium chloride all together. I'm going to take those off and take the mass of the empty filter paper. You're going to pour this mixture, once it's dissolved in water, through the filter paper, let it dry overnight, and weigh it tomorrow. So the way to fold a filter paper so that it will fit into the funnel, I'm going to fold it so that it will easily fit on the balance. You fold it in half like a taco, and then in half again so that it looks like a pizza slice. And when you put it into the funnel, you're going to open one of the side pockets. Not the middle, because then all of your mixture would just run through, but it would be a side pocket. Alright, so far we've gotten all of our masses for day 1. We need to dissolve our mixture of substances into water and then filter it. Let it dry to weigh on day 2. I already did the calculations for mass of calcium carbonate. It was the difference between these two, and it's 0.400 grams. Mass of sodium chloride, I did the difference between these two, and I got 1.079 grams. And so the question is, tomorrow when you have the mass of the filter paper and the residue, will the residue be the mass of the filter paper and the calcium carbonate? Will it be the mass of the filter paper and the sodium chloride? Or will it be the mass of the filter paper with both of these together?
After mixing your chemicals, you need to prep your funnel. This is what's called gravity filtration setup here. We have a ring stand, ring, clay triangle. This is a long stem plastic funnel, and of course the filter paper that Mr. Risner showed you. This is the correct setup. You want to try and adjust the height so that it doesn't have to drip so far, because it tends to splash, so you're going to want to bring that down. Then the filter paper itself, right now, if we were to try and pour in that, wouldn't do a very good job. So we're going to again separate just a pocket on this piece of filter paper, open that up and kind of force it down in there so it's tight, but it won't stay like that without my finger there. So what I'm going to do is take a distilled water bottle and I'm going to just wet the filter paper all the way around so that it sticks to the plastic of the funnel. And then I'm going to use my fingers to press it up against the plastic so there's no gaps between the paper and the plastic. That way nothing can, if you fill it up too much, they can't run down behind the filter paper and into the beaker below. Okay. And there, it's ready.
Okay. So one thing, though these are very safe substances, I also like to keep the tip of the funnel against the glass so that as the liquid runs through it, it'll trickle down instead of splashing. Another reason that it's good to wet the filter paper beforehand, if you picture the paper, which is made of fibers like the mesh on this wire gauze, wetting them makes the fibers expand, and so the holes are smaller and the filter paper will work better. Now when you're pouring your mixture in to the filter paper, you want to make sure not to go higher than the level of the filter. You also want to stir periodically in case there is sediment at the bottom. And you'll see after we pour in what's here, there will still be sediment, and we'll use the distilled water bottle to get out any last residue.
So at this point, the water has completely passed through the filter paper, and you can see that the filter is empty. So we're going to simply lift this out and set this filter paper with the chemical that's still in there that was trapped on a watch glass cover to dry overnight. Here is the filter paper with the filtered chemical or chemicals. Hopefully you guys will figure that out, what's in there. And it is now dry and ready to mass. So for you guys, if you were doing this, it'd be day 2. We kind of fast forwarded this a little bit and used some heat to get it to dry quickly. So it's perfectly dry right now, and you can see the the chemical in there is actually kind of flaky and dry. I'm going to put it on the balance directly on. Nothing's coming off, so I should be able to just mass. I zeroed out this quad beam, so it should be ready to go. And we will see what we have here. Okay, we don't even have 2 grams. Let's see, 1 gram. We have just under 1 gram, it looks like. Let me just get an accurate measurement for you. There it is. 0.900. Right there.
In the next part of this, we're going to show you how to take some stock soft glass tubing and cut it to length and then bend it to what we need for this lab activity. A lot of times labs will just buy straight glass tubing because they have to be cut to so many different lengths or bent in so many different ways for specific experiments. It's just easier for companies to make straight glass tubing and let each lab make their own individual needed materials. For this activity that we're going to do, we need to cut a piece about 15 centimeters in length. You do that using a triangular file. I'm going to put my thumb on a flat edge, and I'm going to use a corner, a sharp section. I'm going to just place it and apply a little bit of pressure, and I'm going to roll the glass tubing forward. All I'm trying to do is scratch the glass tubing with the file. You want to get it to scratch all the way around. If you're not getting good scratches and it feels like your triangular file is dull, try to find a part of the edge that's really sharp. So all you really need to do are get some scratches across, and then you're going to put your thumb where the scratches are, and you're going to bend outward gently. You can see it breaks pretty easily. These are jagged edges. We want them to be smooth because you're going to need to insert them through a stopper at some point and then through some latex tubing. And the way that you make the edges smooth or rounded is by putting them in a flame, and you can see these edges have been rounded. So the part that you're going to put this into the flame is going to be the hottest part of the blue cone. I haven't used these new Bunsen burners yet, so I'm going to start off kind of slow. And I'm just going to roll it between my fingers and keep checking it periodically to see if the edges are rounded. If you leave it in too long, the edge will melt shut. So you can see how smooth it looks now, especially compared to the side that I haven't done. Now, because of the length of these, as long as you get one that's 15 centimeters, you should be able to still hold the middle and do the opposite side, even though this side is still hot.
It's important to remember that hot and cold glassware don't look any different, and you gotta really be paying attention so that you don't get burned.
So we're going to turn the flame off and let this sit for a while to cool. I'm going to prop it up on the sparker so that it's not going to be right on the desk. And we'll come back to it in 5 or 10 minutes. Alright, so I just tested our piece of glass, and both ends are cool enough and they're smooth now. I wouldn't have done this when they were freshly cut. The way that I tested to see if the ends were hot still, not by grabbing onto the end, but starting at the middle and working my way out so I could see if they were hot. So don't just grab onto the end because they still might be hot. Next, what we're going to do is hold these ends. I'm going to be rolling it back and forth in the flame And then once it seems like it's going to be able to be bent, I'm going to take it out and I'm going to slowly bend it to 90 degrees and hold it there for the count of 10 to let it cool off. And then I'll let it sit and cool before we use it. So to end up with a piece like this ultimately is what we're looking for. Now it's important when you're doing this that you hold it right at the tip of the flame. Otherwise those two bright blue parts are going to heat it and you'll get a double bend. I'm just rolling it back and forth in the flame. Make sure you keep it in the flame, that you're not rolling it in and out. You'll start to notice it wiggling when it's just about time to take it out. You can notice it's starting to get a little bit wiggly. I'll give it another couple of seconds. And I'm going to start the bend, take it out, and hold it for 10 seconds. You can see with this, it's not perfect. I did get a double bend. I probably should have held it up a little bit higher in the flame, but it didn't pinch shut, and so it will get the job done. And now I'm going to set this to cool down before we use it. Now that you've got your piece of glassware, you're going to need to very gently insert it into the correct size stopper that has one hole. We're going to use a number 4 today. It fits the test tubes that we're using. To make sure that you're not going to snap the glass, you're going to get it a little bit wet. It doesn't need to be a lot, and then you very gently twist it in. I'm holding it here, not here, because this would torque. This would add too much torque and it might snap, so I'm very gently holding it here, twisting. And you want just a small amount of the glass tubing to be showing through the stopper. Now to do this last reaction, it's going to be a reaction between a metal called zinc and something that's called hydrochloric acid. The 6.0 with a capital M is telling you how concentrated, how much hydrochloric acid there is in this water. 6.0 M might not sound like it's very concentrated, but keep in mind that stomach acid is 0.001 M. So this is 6,000 times as acidic as stomach acid. And for that reason, you're going to want to make sure to wear your safety goggles for this. The other equipment you're going to need: a 250 milliliter graduated cylinder, a pneumatic trough with tubing, a ring stand, a test tube clamp, a large diameter test tube, your number 4 stopper with your glass tubing. I've got some pliers here because you're going to need to adjust this wing nut, and if it's too tight, then you can use the pliers to loosen this. You're going to want to have it so that your test tube is going to be at an angle, and when it's at that angle, you're going to tighten that same wing nut. I've already tightened the test tube clamp to the correct setting here, but the way to do that, you want it to sit gently in and be able to slide in and out, considering that there's a lip to stop it. So you pinch the test tube clamp onto the test tube and then twist the wing nut until it gives you some resistance. And that way you can slide this in and out, but it is securely in there. Next, you're going to fill up your pneumatic trough to about 1/2 to 2/3 to the distance to this hole. You're going to insert your glass tubing into the latex tubing of the pneumatic trough that would go to the hole that's in the bottom here. You can set this here to rest. Next would be to put some of the acid into the test tube. The amount of acid for this is not terribly important, so I'm going to go about 1/4 full on this. Using more would just be wasteful. Because of the fumes, you're going to, at this point, want to put the stopper on the test tube. Next, you're going to weigh out a piece of mossy zinc. This is going to be fine to touch with your hands. You want to make sure that the piece of zinc that you use is not too large. We'll give you some parameters in the lab handout about how large a piece of zinc that you want, what the maximum size will be. So I weighed out my piece of zinc, and you can see how small a piece this is. and it's 0.699 grams. The maximum you really should be using for this is 0.72 or 0.73 grams. And you're going to see in a moment why that is. So mine is very close to the upper limit of what you'll want to use. This may even end up being too much, and you'll see why that is. Your next step is going to be to fill up your graduated cylinder as much as you can, and then use a beaker to gently pour in water until it reaches the top. Once your graduated cylinder is as filled with water as it can be, the goal is to cover it and flip it and have no bubbles. So I'm going to put my palm over the opening. Now this 250 milliliter graduated cylinder can stand on its own for now, but once the reaction starts, you're going to want to hold it into place because of the bubbles that are going to be produced. You want to make sure your overflow tube is into the sink. And when you have everything completely set up, everything is sealed, you're going to drop in your piece of zinc and hold your graduated cylinder until the reaction stops. Now once the bubbles stop, you're going to want to break the seal on the stopper and the reaction vessel, the test tube, because this reaction heats up, and as it cools off, because the reaction is stopped, it will start to suck water in from the pneumatic trough. So it looks like it's done here. I'm going to just take this off. It's important to leave this hanging because otherwise, if it gets below the water level in the pneumatic trough, it will, the water will come out of the pneumatic trough and go all over the desk. So at this point, you can read the amount of gas that's in here. Because this is upside down, it will be reading the correct numbers for the amount of gas. So I've got, remember, each of these marks on here is worth 2 milliliters. And so the best that you can do is going to the milliliter mark. So I'm going to call this 195 milliliters. And if you notice in the video, this wasn't completely sealed. I wasn't holding it enough, and so some gas was escaping. So I'm not going to be adding these results to the class data for graphing because I know that some gas escaped. But I will, just for my own sake, write down 195 milliliters of gas produced. Now, some of the more quantitative observations that you can make about this reaction, that the reaction heated up, that now there is a black substance in the acid, and that the gas produced, it kind of looks foggy, but it's clear. And other kind of observations that you could make about things, especially about gases, are if there's any odor to them when they're released. But one of the properties of this gas that you can test is that if you put your hand and turn the graduated cylinder the correct way. So I'm going to slide this back over my palm to trap the gas that's produced. You can see that it is flammable. All right, so I hope that was all clear enough about what to do. If not, of course, Mr. C and I will be in the room with you. Don't hesitate to ask us if you're not sure, especially because there are some very harmful substances. So remember, lab safety, and it's okay to ask questions in this, all right? So I'll see you in the lab.